Yeah, thank you. So I will be talking about 3D web development indeed. So my name is Tobias and I work at a Belgian startup called Segments. We build labeling tools. So for example, like self-driving companies, they record a lot of data and either for validation purposes or for model training, they need actual humans to like annotate objects and so in those scenes. So for example, we have this 3D interface where you can see a LiDAR scan of a car and you can see like all the objects annotated in it and so this is the sort of stuff that I work on, and yeah, as you can see, it's a 3D interactive application, so on the web, in the browser. So I'll be talking a bit more about how you can build stuff like that today. So maybe first up, why would we even do 3D on the web? Then secondly, I'll go over some computer graphics basics, but yeah, depending on familiarity, maybe we can go over quickly. And then yeah, I'll specifically look at the Three.js library, as mentioned, and also React 3 Fiber, which is a way of using it within the React ecosystem. So first up, why would we want to do 3D on the web? Because yeah, these 3D applications typically seem like quite heavy things, and I think the main answer from like a developer point of view is just distribution. I think the web is a really great way of like having platforms that we can share with each other, and the same goes for 3D tools. If you think about your typical like CAD software from the 70s or 80s, like nowadays it's still often a single player application that lives on someone's computer. And if you want to share a file, the other person has to have a license to that software, etc. Makes it very hard to work together. So it's really good that we have like 3D APIs, so we can do 3D stuff on the web. And from the web point of view, I would just say that it makes it more fun. You can have like interactive visualizations and so, and makes it better for everyone. So some typical use cases. First one is data visualization, of course. Yeah, all kinds of newspapers and so make use of it, of course, to make their data more visual. This, for example, is a project of an artist who talks about like the extinction of certain species, so you can like hover over different areas of the planet. They also have a very fancy animation for when you go to solutions, and you can see it's all very interactive, very nice. This sort of stuff you can build using the libraries that I talked about. For e-commerce, you've probably already seen it, but a lot of websites now, instead of just pictures, offer like some 3D models or even like tryout technology. So this is an example, actually not a functional one, but just to sort of show what you can build with Three.js. Yeah, very nice animations and everything, super fancy. Of course, like I was mentioning, like the actual tools that people use, maybe the most like functional part, so think of like architecture, construction, these kind of things, just 3D modeling in general and so. For example, there's a Scandinavian startup that does basically this sort of stuff for whole building sites. So they have like a 3D and 2D software, both written using Three.js, which is very cool. And then last but not least, of course, also gaming. There's this project of a guy on Twitter who is rebuilding Mario Kart. Although, yeah, he will probably have to change the name for maybe like copyright reasons, but it works. You can drive around, you can even like drift and so. So all very nice that this is possible in the browser nowadays. So basically, before we dive into the web stuff, I quickly wanted to like go over some like brief fundamental concepts, but maybe just a quick show of hands. Like, have you who has worked with like 3D graphics before or taken a course on it ever or something like this? Okay, so some people. So then it's fine. We'll go over it so that everyone's up to date. So when we want to create a 3D scene and we want to render it to a screen, first thing we need is something in the scene, of course. So think of like random 3D objects. So here, for example, we have like a little tram going around. We have all these buildings, other stuff that moves and so. And so typically the way we represent 3D objects is as meshes, because it's easy to work with. So a mesh is like one object, for example. And a mesh itself consists of various things. First, there's like the vertices, which are just sort of the endpoints of all the points around the mesh. Then there are edges in between those vertices, and those make up faces. So typically in like 3D graphics, you would work with triangles because they're very efficient to render and so. And then using those triangles, you can create more complex shapes, and you can even make sure that they get rendered as like a smooth shape. If you want to create a car, you don't want it to be like all triangulated, of course. And then the object not only needs geometry, but also needs color, material, textures. And so here's an example of how such a texture can look like. So we typically like try to fit it into this sort of square texture file. And then basically when we're rendering the pixels to the screen, we're going to do a lookup in that file based on some UV coordinates. But so yeah, this is what it can roughly look like. And then to organize objects in a scene, so imagine, yeah, we have this tram, and this tram has like rolling wheels. It's typically easy to do it hierarchical. So for example, the car contains 4 wheels or whatever, and when I move the car forward in space, the wheels also move to the car because they're like children of the car. Just makes the transformations and like moving things in 3D very easy to work with. So then once we have that scene, all of those objects, we need to decide like, okay, what do we actually show on the screen? And for that, we need a camera. A camera is just a sort of like a representation of like what we're looking at. And so the goal is basically to get all of these 3D objects and to project them to a plane and then actually turn it into pixels. So with a camera, you can like place it anywhere, point it in any direction, you can control it, you can attach it to a user's scroll or something like this. And yeah, you can play with some parameters like the field of view, for example, this sort of stuff. And then what's also important, maybe more of like a side effect, is like shadows and lights, because of course we don't just want to render every color the same in all situations, but it depends like which lights are shining on it and so. So for example here this is like a Three.js example where you can see some different kind of lights. There's like a sort of hemisphere light which adds like a kind of bluish glow to everything. And there's just the directional light above as well that creates this very harsh shadow. So basically we want to be able to work with all of these things, combine all of them together, so both like geometry, materials into objects, then various objects in the scene, as well as lights and a camera. And then the goal actually, which is like a big computer graphics problem I guess, is to take all of those objects and actually create pixels on the screen. Now luckily we don't have to do that ourselves completely, and we can make use of these graphics processing units in our computers, so it all becomes quite easy. So on the web we can do this as well. Like since 2011 there's WebGL, so the web graphics library, which basically allows you to do this rendering, so going from like 3D things to 2D pixels on your screen in the browser. And the way it works is you basically render them to a canvas element. And so it's based on this OpenGL, which is like a cross-platform API that was released in 2007. And nowadays, if your browser is using WebGL, it's more likely that you're using WebGL 2.0, which just adds like a lot of features. Doesn't really matter. But yeah, it took quite a while to gain widespread adoption, but I think now most people have access to it. What's maybe interesting to note, but I won't really go into it in this talk, is that there's also a new API called WebGPU. And the idea there is that the GPU is of course very powerful, and it can do more than just rendering pixels to a screen. Nowadays it's often used for like running machine learning models and this sort of stuff. And if you have to do it in WebGL, it's like really hacky, because you have to basically turn all of your data into image files, into texture files, and set them around to the GPU, this sort of stuff. So now there's a new API that allows you to work with the GPU in a more general way. So you can do all kinds of computations. So in case you're like interested in optimizing some part of performance of an application by using the GPU, definitely have a look at it. The only like big caveat there is that it's currently only supported in Chromium-based browsers, so no Firefox yet, or maybe under a feature flag. But in Chrome, it's already enabled by default. So most people, I mean, a lot of people already access it, not most people yet. But so if we're talking about these browser APIs, then it's maybe good to ask like, okay, what do they actually offer, or what do they actually do for us? And it's quite low level, so I won't go over it too much in detail. But basically what you need to know is that we start with these vertices, so all of these points of the objects. They're like 3D points. And then we want to do some geometry, so like project them to a 2D plane. Make all the little triangles, and then for all the triangles, basically decide which color it is. And then when you do this for all of them, you can basically get like a final composite image. So if you look, for example, at WebGL, if you were to just use like raw WebGL, no libraries or whatsoever, there's this tutorial from Maya that I will be just skipping over quickly, just to show you what the code kind of looks like. So you start by getting your WebGL context from a canvas object. You can set the color to black. And then for the cube, we want to pass in the positions. So for example, these are just like all of the positions of the points of the cube. Then we have the colors, and then finally like basically the edges actually between them, or like how they're linked to these triangles. Then when we have all of these arrays, we actually like always have to bind them to the GL context. Then we can basically send them to the GPU, and then the GPU will compute some programs to create this 2D image. And so they have this special language, the OpenGL shading language, that you can basically program. And so, yeah, you can like attach programs, compile them, a lot of setup code. And so this part of the code basically takes the 3D position and generates like a 2D coordinate for the vertices. And then the fragment shader here, this is like another little program that's gonna assign the color. And then we have to, of course, do this like in a loop so that the browser every second is like updating it. And then there's more setup scene, more setup code. Here we're creating like the matrix for the camera, because WebGL has no concept of a camera. You have to like pass in like the mathematical stuff yourself. Here, more like mathematics to make the cube spin around. Passing all the attributes. And then finally, almost, you get a turning cube. So all of this code, like I even skipped over it, it scrolls down, and so quite a lot of work for just getting a cube to render to the screen, so not the most developer friendly, I would say. So I think if we just had WebGL, there probably wouldn't be too many of these nice web applications, 3D web applications. But luckily, we have abstractions, and we have a great library which is called Three.js, which was started even before WebGL actually existed. So it started out for being a library for Adobe Flash, but luckily they pivoted, and it's it has almost 2,000 contributors, I think. Yeah, a lot of stars on GitHub, very popular. Documentation is quite nice, and they basically provide all of like the common things I was describing earlier in the computer graphics basics. So you have like a class for cameras. So this perspective camera, you just create a new camera. They have all kinds of objects like boxes, circles, spheres, whatever you want. They have lights. You can turn on shadows. You can load all kinds of files. All really great. And more than that, they also have a lot of examples. So basically, this is like a long list. You can basically go to any example and press the code button here, and then you can kind of see how the people, the contributors of Three.js tackle certain problems. So it's more than just a library, it's like a whole like sort of ecosystem of help. And there's even like an online editor where you can create some basic scenes and just like inspect the sort of attributes they have and everything. It's cool. And so just to show you what the kind of code looks like now, I'm gonna steal some slides from another presentation, again with a nice spinning cube. But this time it won't take as long, luckily. So you can see here we're creating a scene which will just contain all of our objects, in this case just a spinning box. Then we're creating a camera, and one of the, for example, the 75 is the field of view that we want, some other parameters, and then we create this WebGL renderer. So that one will actually use the WebGL API to render everything to the screen. Then we create a box, so very simple, just create a new box geometry, so the vertices and the lines between them. Then create a material, put the two together, we get a mesh, then we add it to the scene, so it's in our scene graph somewhere. Now we can change the position and everything as we like. And then we basically just have to create a loop that renders every frame, so the browser will make sure that, for example, on my Windows Chrome, it's capped at 60 FPS. And then here we're just updating the rotation of the cube in the loop so that it renders. So again, the scene graph, and you can create all of these cool animations. You can do quick transforms. You can change the scale, do the rotation. Here again, like the cameras, you can change the field of view, for example. Basically, you can create anything you want, and it's not that hard. There are even some like helper functions in the examples, as I was showing you. For example, that allow you to like rotate the camera on mouse move, which is not like a basic thing in the library, but it's an example, so you can just copy the code and use it yourself. So really useful library, and it's all basically class-based. So then the only problem with that is that it's sometimes a bit hard to plug into these like modern web applications where you might be using a UI framework like React or Vue or whatever. You have some sort of central state maybe that you want to basically pass into both the scene and to some other UI elements that you have. You want to make sure that everything stays in sync. So there is this library that basically takes all of these Three.js fundamental things, like the box and so, and it turns it into React components. And so it's basically creating like a renderer for React that renders to the canvas, that renders 3D objects to the canvas. Also, one idea, this is a quote from the guy who started the project, is that it basically makes it easy to create these components, these to take all this complex functionality, put it into little components, and these components can be shared around, or like different teams can work on different components without like having to deal too much with each other's code and so. So that's like the idea between React 3 Fiber. It's a more recent project, but already 5 years old now, so it's pretty stable. The main maintainer is Paul Henschel, but his Twitter username is very different, and his GitHub username is also very different, so it's all the same guy, but that's his real name. And one really nice thing is that he's not only like saying like, it's easier to share things and so, but he actually created a GitHub repository with a lot of these like shareable components. This is like super helpful for prototyping. So for example, the stuff that's in here, all kinds of controls to be able to control the camera with your mouse and whatever. All kinds of loaders, helpers, all kinds of abstractions that are basically not in Three.js but that are still useful are here, and you can easily use them. And now I'll show you like a quick example of what the code looks like in React 3 Fiber, so that you can kind of see that it looks like typical React. So here we have our application, and we start with this canvas object, which is a custom thing from React 3 Fiber. And then within it, we can basically use all Three.js objects, starting with like a lowercase letter. And we can also create our own components, in this case the box, for example. So you can see here that, again, we added a light. We added 2 more lights at certain positions in the 3D scene. Then we added 2 of these boxes, and then finally orbit controls, which just allows me to like click and drag and change the viewing angle. Then let's see what's in the box. Actually, I'll maybe show you the behavior, but if you hover over it, it changes color. And if you click on it, it changes size. So the way this is done is, yeah, as you can see, it looks like any other code. We have a new state here for the hover and click state. And then basically here we have this mesh. So again, mesh exists of geometry and a material. And we just change these parameters based on the state. And we even, what's really nice about React 3 Fiber is that it actually allows you to get these click events as well, these hover events, which is not something that you typically get in Three.js. But here you really get to do it, so it feels almost like you're doing normal HTML DOM stuff, but you're actually rendering 3D scenes to the canvas. So yeah, super cool. Maybe one side note, if you want to do some kind of user interaction in normal Three.js, the way it works is that you have to create this object called ArrayCaster, which will basically send array, like a line down from the camera, and will check for intersections with other objects. And so then you just get a list of intersections back, and you have to process it yourself. But here it's, in this library, it's abstracted away a little bit. So to maybe show you a bit like the kind of stuff that you can do with it, these are some small examples from a Three.js course. It's very popular online. As you can see, there's like gravity here, and if I move my mouse, I can like make the balls jump around. And the code again looks pretty simple. In this case, they're using like some kind of library for the physics. So you just like wrap it with physics, and then yeah, you can see like it's really not that long. Here we have all of the different spheres again, and the instances just means that it's like a clone of the same mesh over and over again. And if you have that kind of situation, it's better to not just copy the mesh over and over again, because then each mesh will get sent separately to the GPU. And if you use these instances, it only gets sent once, so it's way more performant. But yeah, that's already an optimization. Also, a really cool thing in React 3 Fiber is that you can actually merge like 3D scenes with normal HTML. So here, there's actually a normal like HTML website running under it. So you can see I can like select text, I can scroll on the page and everything. So yeah, you can do some really cool stuff. The techniques here are a bit more tricky, so won't go too much into detail, but basically in this library that I was showing you, there is actually a helper for creating this HTML stuff. So yeah, as you can see here. So it kind of just works. It's a bit more tricky maybe, a lot of these props, but yeah, it's definitely possible. So then, before I wrap up and maybe go to some more like personal thoughts on developing for 3D stuff on the web, these are like some useful resources if you're interested in creating something yourself. Like I said, like the React 3 Fiber stuff, especially if you're familiar with React, it's super easy to get started with. If you're not familiar with React, then I wouldn't suggest picking that up. Just go for vanilla Three.js. You will just have to like read through the docs a bit more to get everything set up, but again, take a look at the examples, they're super useful. There are some people who are doing really cool stuff in the browser. For example, I wanted to showcase this. For the people who have like done a bit of 3D graphics, basically there's a technique of rendering where you're basically calculating how different light rays actually bounce around the scene and so. It can create really cool effects like, for example, reflections and so, because yeah, you're following like the rays of light around and everything, but it's very slow to render. It's only recently that NVIDIA made it so that you can actually use it in gaming. It's like a whole ray tracing thing. But so this library from this guy called Garrett Johnson actually allows you to make these kind of renders. They're not like real time as you can see. It takes a while for all the different samples of light. You can see, for example, the nice reflection effects and the nice like soft light on the floor, and so it's all very realistic. And this is just like happening in the browser on my GPU, which is quite cool. And then yeah, if you want to look at more advanced effects, there are these, you can, as I was already mentioning before, there are these little programs called shaders that get run directly on the GPU, where you can like manipulate colors and do crazy stuff. This is a really great blog post if you're interested in that. And then finally, this one just has a list of tips and tricks of like things that can easily go wrong when working with Three.js. So definitely check out that one as well. And yeah, thank you.
That was actually really cool as well. Questions?
Maybe I have one. So in the example where there are those like two rotating cubes, so how do you make the rotation? I guess like you are not like re-rendering React with like new coordinates?
No, indeed, but so what you're doing in the code itself, maybe I can actually show you. It's in this one, I think. So what you're doing in the code itself is very simple. You're really just like mutating it, but indeed, so you can see here, you have to use this hook, use frame, which gets executed on every frame. And there you just do a mutation actually. So there's this ref, basically, which gives us access to the Three.js object directly. So we're not creating a new object every frame, we're just mutating the same one. And yeah, we're just adding like a little value to it every time. So that's maybe like one of the things that you have to be kind of careful of in general when doing this 3D stuff. Basically every time you create new objects and so, yeah, they basically just get kept around because they're using these materials, and by default these materials and so get shared between different objects if you're using the same material. So that means that like garbage collection doesn't really work. So for objects, you actually manually have to dispose them in Three.js. So that's like one of the typical early foot guns that you can have. If you're just like spawning a bunch of objects, especially every frame or something, yeah, suddenly you can get the all snap page, which I've seen all too well. But yeah, that's maybe for, that's already like a performance optimization, I would say.
How about some native application if you want to use it, for example, in React Native?
Yeah. So the React 3 fiber library that I was mentioning actually also works using React Native. The way it works is, I think it uses like the graphics, like the native graphics actually, but I'm not super sure. But it's definitely supported, as you can see here. Or maybe it's because Expo is doing some of the heavy lifting there for the graphics. That could be. But so it's definitely possible using this library.
Okay, that's cool because I think that many applications you use just in your mobile, like.
Yeah, especially for games and so.
Yeah.
If you don't want to go for Unity or some like heavy framework, this is like very cool for lightweight stuff. I would say.
So actually, are there like any kind of popular games that are running on React Native with this?
Yeah, good question. I don't know. I would imagine that there are some. Maybe we can quickly check it. Maybe some showcase or something. No, those will be normal examples. Yeah. Not sure if there are some bigger games. Probably not yet. But definitely, like on the web, it's like a very popular technique. For example, in terms of data visualization, the people of the New York Times actually have quite some open source libraries for example, streaming in like map tiles and so. So they do a lot of visualizations. For example, there was one. Maybe I can find it back. Where you can basically zoom to to an event. So in this case, let's see if it's, so as you can see here, the camera is actually linked to my scroll. So when I scroll, the camera moves around the scene, and they added some like normal HTML, I guess, on top of it. And what's really cool about this is that when you zoom in, it actually like loads in more information from the map. I don't know if you can really see it, but sometimes you see it like progressively getting sharper. So that's one of the libraries that they have, where you can basically load in these map tiles, for example, from Google Maps into a 3D scene and do stuff with it. So I would say on the web, like if you're seeing 3D visualizations, like the odds are quite high that it's using Three.js. As there are not that many people who want to be dealing with WebGL stuff every day. Yes.
Is it easy in Three.js to render 2D but using 3D hardware as well?
Yeah, it's definitely also a use case. So for example, the architecture tool that I was showing, I believe that for their 2D like floor plan layout maker, they're also using it. And so you can, basically just if you lock the camera to a certain view, you can work with the same sort of objects and so. I know that Three.js in general cannot only use the WebGL renderer, but there's I think also an SVG renderer, but I think that's more of like a proof of concept kind of thing. I'm not sure if it's like good to use in production, but maybe one good thing to know is that right now they're also actively working on a web GPU renderer. So basically in Three.js you will just be able to swap out this one line from WebGL renderer to web GPU one, use the newer one, and then you can do a lot more cool shader stuff, and maybe it will even be a bit more performant for some things. Although I'm not sure if the difference will be that big.
So what is the story when you need to render text and so on? You can go only the HTML route, or
No.
is there some support for like text rendering?
Yeah, indeed. I'm not sure if there is support for like nice text rendering with fonts and everything in vanilla Three.js, but I know for sure like here in these helper functions, so in this library called Try, they actually have this helper component for text rendering, using like signed distance fields, which I think is also used in like the game development industry for rendering text. It's a bit tricky because you cannot just use the browser's text rendering. And I remember actually recently there was a YouTube video of some guy who wrote his own text rendering thing, maybe you saw it, but it was awfully complicated. Even the like open type font specification is like 300 pages or something like this, so it's complicated.
Yeah, we thought about rewriting some in the previous startup. We thought about rewriting some of the stuff that we did in WebGL
Yeah.
because we did some stuff in Canvas, but the problem was that for it to be performant, we needed to cache it, and because of the cache, Safari would crash because like you would take up, I don't know, 400 megs on iOS, and then it would be like totally dead because Apple didn't update the specs, and even like in Chrome and so on, you would eat like 2 gigs for one tab, and like it would all be quite smooth, but it would eat a lot of RAM. And so we thought about rendering everything in each frame, and basically the text would be just crazy terrible. And shadows, that was a big problem as well. And as soon as we would, use HTML and so on as well, basically we would have all the synchronization problems. So that would make everything slow again. So it was like every time we thought about something, we would end up with like, okay, it's still slow. So I was just wondering if you have some experiences with that, like rendering text on.
Rendering text not specifically, but it's definitely a problem. But so there are like techniques, I guess, to do it without implementing a whole like text rendering engine yourself. There's actually also, maybe I should mention it, if you're planning on ever using like the normal vanilla Three.js, there's also a similar library called Vanilla by the same developer collective. The thing is just that the list is a lot less small, but actually they do have the text abstraction. So maybe you can check out if it is what you want. So you can see that the text looks pretty crisp, even if we rotate around it and so.
Okay, thank you for the tips.
No problem. Yes?
You were showing like examples with primitive shapes, yes, like the square, some circles, physics. But if how the process of like developing of complex scene, like if you want to control like a square, like a tree, is it possible? How is this compared to like 3D scene rendering software?
So wait, could you repeat the last part?
Well, I mean, if you want to draw like a complex shape, yes, how do you proceed? Because you cannot like you need some set of coordinates.
So
curves and all these.
what you're asking about is more like you have an idea in your head, like you want to have a nice tree in your scene or something.
Yes,
and
something
how
like
do you
this.
get it? So typically, the first step that you would do is just look online if there are like good models of trees, because there are a lot of these artists that create 3D models and they sell them or they're available for free. And Three.js has a lot of loaders for different model formats. So you have like OBJ, for example, or GLTF. You have like different kinds of file formats that you can load in Three.js. So you can use those to populate your scene. So you don't actually have to you don't have to define the coordinates like in those examples, luckily. There are also different techniques. If you don't want to be working with meshes, for example, there are like new techniques that allow you to make scans of an object using your phone and then like visualize them. But then you cannot, for example, just do physics on them and so it's nice to have a mesh.
I mean, you have shown some code rotating and well, there are some physics there, like
Yeah.
or something like this. So how do we do this?
Yeah, so you start basically, you get a model of the tree, you import it into the scene. So you use like the GLTF loader, let's say. So then the model exists in your scene. And then the physics thing is, it's a component that you just add. It's imported from this library called, forgot the name. Anyway, it's a library that you can just install from npm, and it basically does the heavy lifting for you. So it's made in a nice modular way so that it basically takes the objects in your scene and makes them drop and calculates the collisions and so on, so you don't have to think about that yourself. And then, yeah, if you want to create interactions, like that's one of the hardest parts, I would say, in general, because I think in normal web development, it's kind of like the interactions are kind of simple and maybe well defined by now. You know, you have like your scrolling, hovering, clicking, double clicking, right clicking, this sort of stuff. But in 3D, it's often not clear, like, okay, imagine you want to allow the user to shake the tree, like, okay, what should they do, in which direction should they move their mouse, how long should they click on it, or this sort of stuff. So I think that part is the more interesting part. The part of like modeling and getting objects into your scene should be like fairly simple, I would say. Yeah.
Well, for example, like take a use case like shop or like boot shop. Like is it possible like to like they release a new like running shoe and to show it like realistically? That means we need to create a model, like detailed model. This is a lot of like.
Yeah. So indeed, so probably.
Then we can like run in some physics. Physics is okay. Physical model exists, but creating a model will be a lot of.
Yeah, true. So if you would use like a normal 3D artist to create a model, indeed it will take a lot of time. But that's where probably like these 3D rendering, there are basically new techniques of capturing the scene without creating a mesh. And you can still render it in real time in the browser. One of these techniques, which is really like new, it's from like 1 year ago, is called 3D Gaussian splatting. It's from this paper. And I can show you an example maybe of what it looks like. If there is one. So for example, this is a scan. So this is just based on pictures of a train. And as you can see, well, it's not perfect because there are some of these like floating artifacts, but if you just stay within like the normal zooming angles and everything, then it is actually like pretty realistic, the different views. So this is a different technique. Instead of like having these meshes that I was describing, actually there are different ellipse shapes in this scene that basically they're optimized in such a way that it looks realistic from the different angles. So you can use these kind of techniques. It's actually also integrated into Try. Maybe I can show the example. And indeed, I think for like the e-commerce use case, it's actually quite nice. I don't have storybook, I think. Yeah, let me try to look up the tweet so I can show the example. Yeah, well, in any case, you can do this on the web as well, and you can integrate it into your scene and everything. Maybe one last little resource I can share if you're interested in creating your own models. There's this 3D modeling tool. It's called Spline, and yeah, it's free for basically like the typical things you'd want to do. And you can basically create your own sort of shapes and models and scenes in the browser, and then you can export them and you can import them again into Three.js, for example, and add some fun interactions. But they also have a lot of objects already. They have a library of, for example, here like a bottle. You get a wine bottle for free from this library. Okay, now I have a wine bottle in my scene. Or there's even an AI generation button, but of course it's behind the paywall, so I cannot show it. But supposedly, if you give a description of your object, some model will generate it for you. So.
That's cool.
So it's becoming easier and easier to create these 3D things or to scan them, but it's like, yeah, the technology is still actively being developed, I would say.
Great. Thank you very much.
Thank you.